Okay, recording. So let's create a new project. Solution 2023 paper B. Toyamo paper B. (2023) paper B. What's that? Let's read the paper. What's in one? Artificial immune system. The Utopian Health Institute is currently conducting research on the way in which the human immune system adapts to foreign pathogens. So, as a starting point, you have been tasked with creating a very, very basic simulation of the human immune response. So you have been provided with a set of rules that your simulation must apply to each detector whenever a pathogen is injected into a person's body. Oh, so I don't know if you're in your head you are thinking of, like I will just write the scenario. I don't know if in your head you are thinking of whatever they're saying here. So it's like that they want to do a research, to conduct a research and and check how a human immune system responses to a pathogen. So it's like, example, you go to the doctor, they inject you with a pathogen. So they want to check how your immune system responds to that pathogen. So now, when I was reading this, I'm busy thinking it inside my head. So lena hilibala since itlika peluna ganorish. No, didn't. So detectors are black circles and pathogen ladima. Ibijang into lightning bolt. Yeah. So the simulation does not require the user to control any of the game's features while the simulation runs. The simulation does not require the user to control any of the game's features while the simulation runs.
Yeah? Can I ask?
Yeah.
So, like, since the simulation does not require the user to control any features, so like to be happening on its own, like
Yeah. It will be happening on its own. I think maybe for us we're just going to click one button that everything happens on its own. Like there is just the detectors. I don't know whatever happens in the body when a pathogen has been injected. So maybe the detectors, they detect the pathogen and run, chase it. So yeah, those things are going to happen on their own. Maybe I think we just press a one button, then boom, everything happens.
What's a movie?
However, the simulation configuration is controlled through either command line arguments or user inputs. I think here maybe we choose. I'm not sure what they're saying. However, the simulation configuration is controlled through either command line arguments or user inputs. I think we will get it as we read through the question paper. The simulation aims to see how pathogen detectors in the immune system attack a pathogen when it is introduced into the system. So yeah, I think with Tina, what we are going to do, I think we are only going to click a button to inject a a pathogen. Then in the world, we're going to have pathogen detectors. So those when those pathogen detectors detect a pathogen, they're going to attack it, wara stuff. So the simulation will run into the simulation will run into distinct phases. Okay, phase 1 allows the user to configure the simulation settings. To configure the simulation settings, oh, now I get it. Phase 2 simulates the immune reaction whenever a pathogen is introduced into the immune system body. The immune system is represented as a dynamically allocated two-dimensional array. You must place the game in the AI, AIS, AIS space namespace. So yeah, let's. So what you want to do first of all, is you create your header file and your source file. Like the first things you do when you enter, create your header file. I'm going to call it AIS. Okay, then always remember to click these things. If you don't click these things, oh my god, going to see a movie. You're going to kill yourself after writing. So you must remember to click these things. Then let me create the source file. I'm going to call it AIS also. Then click these things, debug and release. Otherwise, then Sabo, after creating your header file and source file, so after creating your header file and source file, what you want to do after creating your header file and source file, what you want to do is do the linkings. So you go to your CPP file and you link it to the header file. So you include the name, the header file, AIS.h, then and you also include it under main. So include is, then these ones I'm just going to include them in the header file. Then at the same time I what's this? I declare my namespace. What's this? What is it? Is it called? So I'm going to do my namespace. I'm going to call it. Sorry. I'm going to call it. They said we must call it AISS space. So yeah, I'm going to define. Oh, defining. I'm going to define it, and I'm also going to define it in my source file. Then in my what's this, in my main CPP, I'm going to use it using namespace AIS space. So then boom, I'm done with my linking. So in the main, you include the header file and use your defined namespace. In your header file, that's where you include the header files. Then you use namespace std. Then that's where you define your namespace. Then in under source file, you just include the header file and you declare your namespace. You define your namespace. Then you're done with linking. So that's the first thing you do. Like when you more computing, that's the first thing you do. Make sure you do this. Then the second thing, overload your main function. Int axi char printer, args. Some people use argv. They say argv, but then we say args. We can choose any. It's still the same. Doesn't matter. Okay, then I've overloaded my main function. Then the second thing I want to do is to declare my two functions to convert from my two functions, my generating random numbers function and my function to convert strings to integers. First thing, generate random, then I pass the lower bound and I pass the upper bound. And you remember, to generate random numbers you need std so this is std lib.h. Then this is hashtag include c time for seeding your random numbers. So c time. Then then you also declare your function to convert strings to integers. Okay, then you pass your string. You need to call it string now. Then to convert a string to an integer, you have to include the header file as stream, or it's as stream, like this. Don't forget, without this you have to have those. Then example, I'm going to implement them in my source file. Okay. Then this is int range supposed to upper bound minus lower bound plus 1. Then return rand modulus range plus lower bound. And that's my function to generate random numbers. Then here I'm going for converting to strings. So to convert to a string, we say we declare our int num. This is int num. It's so that I do not forget to return it. I'm just going to return it now. Then I'm going to declare my string. So you see it will automatically appear here, just in case you forget it. Then ss. Then you pass your string number. Then you're going to say ss. It's like you're again now in ss you're putting in the string number. It's like you're taking that string number and you're putting it in int num. So don't forget that here you must put int num. Someone did a mistake and put string num. Then you're going to check if ss.fail. Server operation has failed. Operation failed. Right, what's that? And line, then exit. So we want to declare your error codes. Error codes. We have success. But then for my error code, I want my error code for invalid number of arguments. I want it to be -2. Then I want an error code for convention. I'm just going to call it conv. So automatically this one will be -1 and this one will be 0. So here I'll just use my error code. Waiting. Then here I will return success. So yeah, that's the first things you do. Then you go read your paper. So initialization, phase 1. So the size of the array, rows and columns, and the number of initial detectors are provided as command line argument. You're going to go pass you're going to declare, you're going to pass your command line arguments. We have the number of rows, the number of columns, and the initial detectors. So say they're saying initial detectors, it means by the end of the game they're going to be more than that. So our initial detectors, let's have 10. This is a big row. Let's have 10. Now let's have 20 detectors. Let's have 15. Let's have 15 initial detectors. So Sharpo, so you get that you have to have the size of the array, the rows and the columns, and the number of initial detectors. So now you know how many arguments you must have. So since
Yeah.
these are 3, it means the number of arguments must be 4. Counting with index 0. Was it
Oh.
was it to know how many axes, how much axis you must have? You must just calculate how many die here and plus 1. So this is 1 2 3, then plus 1 must be 4. So now you know your number of arguments must be 4. So we're going to use
Okay.
assertion. So to use assertion we must include C assert.
Assert.
Yeah. So C assert. So we're going to use assertion and check if our number of arguments are correct. So I'm just going to say axis equals to 5. Is it 4? Yeah, it's 4.
4. Yeah.
Yeah, remember assertion. If you forgot the assertion, you must remember that you give it a condition that must be true in order for your program to run. So we want our number of arguments to be 4 so that our program can run. So in case our assertion fails, you want to display a message. So just say invalid number of arguments. So then you can just specify how the number of arguments must be. So it must be rows called followed by initial ini- initial detectors. Okay, then that's my assertion. Now I can seed my random numbers. Yes. Run time 0. Alright. Remember to comment. We are not commenting. Remember to comment. So then yeah. So what I'm going to do is that I'm going to declare my variables that I'm going to get from my command line argument. So we have int rows. So some people don't understand why they say size when what they mean when they say size of the world, the size of the array. When they say size of the array, they mean the rows and the columns. That's the size of the array. So when they say size
Oh.
of the array, they're just referring to rows and columns. So yeah.
Okay.
So we're going to convert that to an integer. Is that x1 then int calls x at 2. We have detectors. Detectors detectors. Aye. This is what you do. You store your variables which you are getting from the command line arguments. Then now that's when you can move on. Size of the world, size of the array, and the number of initial detectors are provided by the command. So you have passed them, then you have stored them, so you can move on. So detectors are placed randomly throughout the array. Detector cannot be placed on top of another detector. At the start of the simulation, there will be no pathogen present in the system, only detectors. So right. So so at this point, so you have done all of this. No, so now you have to deal with the 2D array. So that's when you decide, am I using record structures? Am I just going to declare my 2D array? Then you're like, no man, let me have my record structures so I can have my marks. I will need those 5 marks to qualify. So let me just use record structure. Then you decide to use record structure. So call it game world. You can call it what you want. We are calling it game world. Me and you. So we're calling it game world. And in our game world, we're going to store our size of the world. Size of the world, remember, we are referring to the rows and the columns. So we're going to store the size of the world, which is rows and columns. That's the size of the world, rows and columns. Then we're also going to store our 2D array. That's going to call it grid. Okay, that's our grid there. So remember, this thing, game world, is a data type. Because I see some people sometimes they confuse it. This from now on, this thing is a data type. When you use it, when you are saying game world, just know you are using a data type. It's a record structure, but then it's your record structure. You are defining your own data type. This game world is a data type. So use it like you are using any other data types. So let's continue. So we're going to come in main and declare our game world. See, game world is a data type. Then I'm going to call it. So normally I call it world. I'm going to call it world. Right. We have our world. Game world is a data type. So we have world of type game world. We have world of type game world. So now we have our world. So remember, we have to assign. So at the moment, the rows and the columns have not been assigned. So we are using a setup function to assign those things, those so those rows and columns. And it depends what else you have in the record structure. So of course at the beginning you won't know what else you must add in your record structures, but then as you read through as you read along the question paper, you will know, you will figure out to know this one, let me add it in the record structure. Like it depends on what you want. Like these things is not a must story. I must do them this way, do them this way. No, you choose how you want to do your practical. You choose how you want to solve your problem. So we are solving problems here, and the solution is not the same. As long as that the solution that you are making is solving the problem, so it mustn't be the same. There's no exact exact solution to solve the problem. No, the solutions are different. So don't think, or you must cram this, you must do this exactly. No, you can use your own thingy. Just think and decide what do you want to do. So we're going to have a function when we call it setup. Okay, setup. And we're going to pass our game world. So as I said, game world is a data type. So I'm going to pass a game world. I'm going to pass it by reference. I'm going to call it world. Game world is a data type. Then I'm going to pass the number of rows, the number of columns. Okay, that's my setup function. So yeah, let's just assign our fields world dot rows equals to rows, world dot calls equals to calls, then world. Oh, don't have anything else. So yeah, so after declaring your game world, you're going to set up your game world. Setup, then you pass your game world, then you also pass your size of the array, rows and columns. Alright, so that's our setup function. So each time to be on the safe side, you should run every time to check if you are still doing correct things, if there are no errors. Because if you want to act like a genius and code the whole thing, hey, when you run at the end, you see, hey, you won't be able to debug your program. You see errors there. So run consistently. Yeah, consistently. So we are going to set up our game world. Then after setting it up, we're going to allocate memory for our grid in our game world. So alloc, that's going to call it alloc. Then from now on, I'm just going to pass in my game world. Okay. So each allocate memory goes with the allocate memory. So I'm going to say the alloc and pass in my game world by reference. So and my initialize function. Right, init, just to save time, init alloc dialog. So just going to call them that. Then I'm going to implement these three functions. Okay. For my allocation of memory, so it's world dot grid equals to new int pointer, then world dot rows. All right, then for int r is equals to 0, then r is less than world dot rows, then r plus plus. Now this will be world dot grid at r equals to new int, and this will be world dot calls. Yeah, even this one people may make mistakes, so you have to remember, first one, you make an array of pointers, that's why you say int pointer. Then the second one, you make an array of integers, that's why you just say int, because it's an array of integers of size calls. The first one is an array of pointers, that's why you say int pointer. Then of size rows, then you loop through that array of pointers and you allocate memory for each pointer. So each pointer is going to point to an array of integers of size calls. Don't forget the first one, array of pointers, that's why you say int pointer. The second one is an array of integers, that's why you say int. Right? Alright.
Yes.
So in the deallocate memory, we're just going to loop through our array of pointers. So here again, I said this is an array of pointers. So we're going to make an array. We're going to make a for loop to loop through our array of pointers and delete each pointer. So int r is equal to 0, then r minus h is less than row world dot rows, then r plus plus. So I'm going to delete each pointer. Great pointer at r. Just delete. Yeah, I'm going to delete each pointer, then afterwards delete the whole pointer. World.greet. Then now we're going to delete the whole pointer. Then you can make it equals to a null pointer. That's your decision. No matter what decision. So under initialize, that's where we place our features. This. I'm going to declare my features. Number of features. So int features, you can call it characters. Int features. So we have space. We also have a space. Then we have, this will be 0. Then we have a, oh, what do we have? We have detectors. So we have a detector, detector. Then we have a pathogen. Then we have a pathogen. Right, we have a pathogen there. Then we want to make an array of characters. So I'm repeating this again. When you are declaring a variable in the header file, you must declare it by constants. So Abanamoki, we're just defining here. We're just defining the enum. This is not a variable. We're just defining the what. Even this record structure. Remember, I told you game world is a data type, but now here we're not declaring it. Like we're just defining it. So when you are declaring something in your header file, you must declare it by constants. By constants. Anyway, so I'm going to say const char. So I'm going to declare my array of characters. Then I'm going to define my values in time. So we have a dot. So this thing corresponds. You start with a space. And then what's the second one? Is a detector. So what's the thing to represent a detector? We can use a @ sign. Then you check what's the second one. Is a pathogen. Then you decide what can we represent a pathogen. We can represent it by this exclamation mark. Is it an exclamation mark? So I'm saying exclamation mark because it's foreign. So the question mark is like, bruh, why am I? What is this? So yeah, in our initialize function, so we're going to first of all we're going to place spaces everywhere. So okay, let me place spaces. So as always, we're going to look through our grid. To look through our grid. When you copy and paste, remember to check if you remember to update these things. So here it will be calls. Also don't copy and paste. It's my right. Why am I saying don't? You will anyway. I won't be there. Then yeah, I'm just going to place spaces everywhere. So I see some people here, they say game world. Bruh, game world is data type. You have passed your world there of type game world. Why are you coming here and saying game world? You have world there of type game world. So yeah, I want to say world dot greet at r and at c. And sometimes some people maybe you forget, and I also do that. You forget, maybe you just come here and say world, then you say r and at c. Oh no, must set the grid, and that's when you can say r and c, and not just place spaces everywhere. Space. And yeah, we also have to place the detectors. So let me just place the detector. Place detectors. So here obviously we're going to use the initial number of detectors. So it means since we are not storing the number of detectors in our record structure, so it means we must pass them. So we're going to pass our number of detectors. This is num detectors. Okay, so when I update the function signature in the source file, I must also update it in the header file. This is what we call the function signature. It's argument and stuff. Then yeah, so we're going to look through our number of detectors for int t equals to 1, t is less than or equals to number of detectors, then t plus plus. Okay, so we're going to generate a random column, a random location. So when we say location, we're referring to the row in the column. So it's not like it's a one location. So when you say random location, when we talk about a location, we talk about the row and the column. A location is defined by a row and a column. That's why when we say a size, the size of the world is defined by the rows and the columns. So when we say size of the world, we mean the rows and the column. So also when we say location, we mean the row and the column. So we're going to I grew up placing our detectors randomly across the grid. So we must generate a random location. So it means we must for us to have a random location, we must have a row and a column. So we're going to generate a random row and a random column to come with a random location. So let's have our random row. So we're going to generate, this is from 0 to world dot rows, okay, dot rows minus 1, dot rows minus 1. Then we're going to have our random column generate, this is from 0 to world dot calls minus 1. If you see your if you run your code and you see it returning minus something something something, it means you have an out of bounds. So you must go check your location, or are you saying rows minus 1? Are you saying calls minus 1? If you see it returning minus 2, blah 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 blah, random values, then you must know, no man, I must be going out of bounds somewhere. So you must check this thing, or did you say rows minus 1? Did you say calls minus 1? I hope that's clear. Then now we have our location. When we talk about the location, we talk about the row and the column. So now we have our location. So this is a random location. So we're going to check if this location, if at this location, if this location is being occupied by something else, or is just being occupied by space. So we're just going to check if this location we got, if it's occupied by a space or not. So we're going to use a while. So while world dot greet. So at this random location, I'm going to check. I'm going to check. Oh, I'm going to check if this location is occupied by something else. So we are just saying if it's not occupied by space. So obviously if it's not occupied by space, it means it is being occupied by something else. So it might be occupied by a detector and stuff and stuff. If it's occupied by something else and not space, we're going to generate a new location. A new location. So we're going to generate a new location. So a location is defined by an RNC. So we're going to generate a new location. This is us generating a new location. So if the location we got here, that location, there is something occupying that location, this while loop is going to generate a new location up in, until the location the location that's being generated, there is the location is occupied by space. Then we'll know now it's safe for us to place our detector because there's nothing occupying the space. So we're just going to place our detector. So yeah, that's our initialize function. So I'll come to main. After setup, I'm going to allocate my memory. So I'm just going to pass my game, why do I like saving game? I'm going to pass my world. Then before return what I'm going to deallocate, deallog, pass my game, my world, my request structure. Then after allocation of memory, I'm going to initialize my world init, then pass world, then pass the number of detectors, so initial detectors at this point. Then I'm going to display. Did we do the display function? No, we didn't. Let me do the display function. So void display, just need my record structure. Just need my record structure. My record structure. We implement my function. As always, we look through the 2D array. Let me just copy this one. So we're going to say cout world.greet r init. Don't forget to make a space. You guys forget. You must make a space. Then you do this. Then here you make sure you go to the next line. Don't forget. So let us display world. Okay, that's my world. Oh, I didn't use the array of characters. Let me go use the array of characters. Then boom, that's my world. I don't think you guys realize or simulation is the one that's easier and quicker and faster. I don't know. So like at this point we have displayed, we have allocated to memory, we have initialized, so we already have like a lot of marks of it. Simulation is not as difficult as you think.
Let's count marks, yeah.
So design, would you guys even have time to do the design? I want. So we have design 10 marks. Then we have this thing, boilerplate code, namespace, system library inclusion, indication of successful termination program. So that one, okay. So yeah, so standard namespace is using namespace STD. Then system library inclusion, that's just referring Gucci. Are you including your names, your header files? That's it. Then for indication of successful termination, if this thing if you run it and at the end of the thing it returns 0, so that's an indication of successful termination of program. So far you have 50 marks. And coding style, coding styles you always, so naming of variables, obviously in the indentation, I don't know what that is, but then obvious use of commands, you will use commands. Then use of name constant, so you see this thing, name constant, we're using it once in the header file when we are declaring our what of array of characters. So that's where it comes from. Then program compiles without issuing warnings. I think mine doesn't issue warning. No, it doesn't. And yours must also not. So we have 20 marks so far. Then functional abstraction. This thing is what you are doing. Text decomposition. How should I explain it? Reduction of repetitive code. But then yeah, you always get it. This is what you are doing. Yes, I don't know how to explain it, but then just know you did it. We did it. So this is plus 10 marks. So, so 30 marks. So this one, separation compilation. So I mean, we started by doing this thing. So when I said, firstly you link, you do your namespace, you do your header file. This is the 10 marks already. That's why I told you do this thing first. So already you got it.
What's our cut conditions?
That conditions are in your header file are these things. If not defined, if defined, those are that condition. So that's why I said start with these things. So these are 10, you are 10 marks. Then here we are not displaying the menu yet, but then obviously like a menu, don't display what's a file. So just say you're just going to take it as we did the menu. So the menu, so this one, appropriate use of input is when we use C in, then appropriate use of output, we use C out, then appropriate use of streams, this is C error. So I showed you a certain idea. So this is 10 marks. I'm not bit okay. So plus 10. So already you have 50 marks. Then you come here. This is the use of command line arguments. So you have overloaded your main function. The main function just by typing this out is that's overloading your main function. So you have overloaded our main function, then we have handled incorrect number of arguments. We have handled with assertion. Then we use supplied arguments. So you see, we stored them and saved them, then we use them, rows and columns, we use them. So we got the 5 marks here. So far you have 55 marks. Then error handling, use of assertion, use of conventional error handling techniques. This one I'm not sure what they're saying, but then can I'm sure more handling the error is this Timochi. Which is that? Mochi if what then you're also going to handle an error under switch. You see that default when you input an invalid what, so that's it falls under this thing. So
error handling.
So yes, you are going to do it and no maganjan, don't need it. So that's 5 marks. So already you have 60 marks. Then remember I told you start with a function to generate random numbers. So you have another 5 marks. You have 65 marks. And here we're using structures. We have allocated memory. We have initialized and we have allocated plus 20. So we have 80 mark, 85 marks.
Already.
So don't. Simulation is not difficult. Already we have 85, and we like essentially remove detectors, but we have 85 marks already. So simulation is not. I don't know. You guys think it's hard, but it's not. It's actually not hard. It's not the same thing. You're not quicker, even shorter. So
Yeah.
let's kind of good.
You make it look easy.
Yes, Kilungelo. Yeah.
Yes. So both cancer semester test 1 mark, semester test 2 mark, or both semester test 2 mark fell.
Semester test 2 each ke 60% of king ke nakelewech like the
5%.
yeah
Both it's 2.
yeah both jadi 2 mara adi percentage one semester test 2 year percentage inch ogar ke 60 actually 60
Yeah. 65.
65.
or 65 then semester test 1 actually yeah how many marks yeah how many percentage yeah how many
5. Guys.
yeah how many
35.
35.
oh 30 yeah 35 then the remaining I think the remaining is 10 if I'm not mistaken Kiona?
Practical.
25.
Huh?
For qualification or into working waiving?
Enge?
For qualification or
So I think they're saying for semester mark. Yeah, for qualification it's like for semester mark. Mara for qualification they know they about checking semester mark fair. They also check what's that thing? Practical component mark. So practical component mark by calculator but semester test 2 they the practicals fair. So both semester mark and both semester mark and practical component mark they must be higher than 50 both of them or qualify as a semester mark fair like gusa.
Sorry.
Yeah.
If I can ask,
Mm-hmm.
for the practical marks, they also include those activities in VPL, ne? Not only the practical activities that we were submitting every Friday.
No, VPL Innova like it's just so for in case if you have not been doing your practicals, then they will go check if you have done your VPLs. So those VPLs will little touch so like if you have not been doing your practicals, so if you are in delay the VPL, so it's like yo how to go tell you uh 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 so VPLs like if you have not been doing your practicals, so they will go check if you have done your VPL. So if they find that you have done your VPLs, so those marks like those marks for VPLs they're going to substitute those ones for the practicals which you did not do. I get what the was in
Oh, which you did not do.
yeah, sort of like if you did not do your practicals, the VPLs, the Marakata VPLs, like the to shower I saw them talking about a movie. Nah,
Kuba was asking, I have something.
sure. I'm gonna share.
Yeah, guys.
Essentially, Rabon Mara. Yeah, Rabon and one.
Exactly, like class test, lead assignment. I'm sure the working practicals, ne? 10%. Semester test 1, that one that we wrote out of Word, I'm sure it will be 25%. Then for this one that we're writing, 65. Then they combine these three to get a semester mark here on, which will make us qualified. But yeah, 40% for the module or semester mark. And then yeah. I don't know about 70% part.
Let's go to the 70% part.
They didn't talk about it here.
I go with him. Mola mo barenge barenge bare
Oh yeah,
yeah, promotion as you will.
Your semester mark, it is possible to get to promote computer science 1A.
You can promote computer science 1A in both for
your semester mark is greater than or equal to 70%. If you promote, then you do not have to write exam. Semester mark automatically becomes your final mark.
Yeah.
So semester mark is this one, module semester mark, mixing assessments, assignments, test 1 and test 2.
Yeah, that's the semester mark.
Okay, come on. All right. So if you really do good, more semester test 2, your test 1 and the practicals will complement or maybe will create 70%
yeah. So tanto ko sasali make sure like volaya. Right.
Okay, I think that's enough, isn't it?
All right, then let's continue. Sharing.
Yeah, let's continue.
So can I ask, guys? Has practical 9 been marked?
I don't know about that one.
No, it hasn't.
Oh, but will they ever make it, or now that we are done?
Maybe they'll make it.
All right. Yeah. Bare kudiang kazulu. Utotshala pele kazulu kudiang. Saya penzulu. Bare kudiang. Anyway.
Siyaqhubeka.
Yeah, saqhubeka manje.
Siyaqhubeka.
Eish. Asiqhubekeni.
Xwela, bra.
Ayixele Braga. Hey.
Hey, sorry, before we can continue, ne?
Yeah.
Can we quickly check? I just want to check the struct and the setup function. Yeah, the setup those things.
So this is our structure.
Yeah, so there's the rows, column, and the grid. Ne? Okay, and then the setup function. Can you open them in the implementation? Oh, so you don't set up the grid, ne? You only set up the rows and the columns.
Yeah, rows and columns. Grid you set it up in the allocate memory. So the grid is only to be allocated, not set up, not for setting up.
Okay, okay, all right. I think I'm fine.
All right, let's Kubega.
So guys, before sorry.
I can talk.
Back to
Can
the setup function. So renally setup function and display function. So meaning in this setup function, world.rows equals to rows and world.columns is columns. Meaning for here we are setting up only I display. You can't display using this setup. Meaning like after allocating memory. No, before allocating memory, how set up, like you don't use the setup to like maybe display or
yeah. You only use it once. At the same time after declaring your record structure, you only use it once.
oh, okay. But you set up, you allocate memory, you initialize and then display.
Yeah, in that order. Setup is the first thing you do.
Okay.
Some people maybe make setup somewhere else. No, setup is the first thing you do.
Okay.
Then you allocate memory, then you initialize.
Oh, okay. Thank you.
So yeah, I wanna these 5 functions. Hey, very important. 1, 2, 3, 4, 5. Very important.
Yeah,
So yeah. So as to begin. So detectors are placed randomly throughout the array. A detector cannot be placed on top of another detector. Okay, we have done that. At the start of the simulation, there will be no pathogen present in the system, only detectors. So this point, I think we must do it using that that do while loop and stuff. But we will see. This is over Pambi. So phase 2. So just like that we did phase 1. Really. Wait. Okay, let's continue. I'm guessing that something is going to change here. Then let's continue. So simulation. the simulation runs only if there is a pathogen present in the system. Oh, that was initialization phase 1. Phase 2 is simulation. Okay. So the simulation runs only if there is a pathogen present in the system. Only if there's a pathogen present in the system. So yeah, the simulation runs if there's a pathogen present in the system. So let's check. So if there is no pathogen in the system, the user must only have 2 options. Introduce a pathogen or quit. So when the user introduces a pathogen, it must be placed at an empty random location. If there is a pathogen present in the system, the user must only have 2 options. So it's so Barry, if there is no pathogen in the system, the user must only have 2 options: introduce a pathogen or quit. Then they're saying if there is a pathogen present, if there is a pathogen present in the system, the user must only have 2 options. Okay. So the simulation runs only if there is a pathogen present in the system. Make sense. First point, Barry, the simulation runs only if there's a pathogen in the system. So if there is no pathogen in the system, the simulation doesn't run. The user must only have two options. Okay, let's implement that. So I guess we'll use the initial detectors. So I think this is safe to use an if statement. You can even use a switch. Yeah, using switch. Use it. We are using if statement, but then we can also use a switch. So we're going to say if initial detectors are greater than or equals to 1. So if this is true, it means the pathogen is present in the system. Okay, else if you can just say else if. So else if initial detectors are less than or equals to 0, it means there are no pathogen present in the system. Switch. So if we negotiate if state if negotiate if statement to do the sorry. If you have a switch more yeah, it's more sharp. I'm a if state. Switch. So I think this thing, as always, we must do it in a do while loop. We must use a boolean continue and stuff. Cause they're saying quit. So everyone quit mola. It's obvious, or we must have boolean continue shit. So in my record structure, I'm going to go to my record structure and add the boolean continue. Like it's your decision. If you don't want to add it under the record structure, you can just declare it here and say boolean continue, like as a false, as a must. Can you make it equals to true? Now, so it's your decision. So marana is not decision add under record structure. I'm going to edit in the record structure because it's my decision. Then in the setup function, I'm going to make it equals to true. So world status. So each time you add something, you must check if you are setting it up in the setup function. So remember, if you declare a boolean, if you're just declaring a boolean like this, you're just saying bool status, automatically value on like a false, and so you set it up to true. So see how I'm going to use the do while loop. I'm going to say do while world dot status. Then Kamoda, I'm going to use a switch myself, and I'm going to switch through the initial number of detectors. So we're going to have two cases. So case amatomo, it's if k is this possible in, so this is case case greater than or equals to 1. Can you C++, can you do this in C++, or it's just informatics, it's just in let me check what let's check if it's possible. In case 2 can C++ another case else. carry C out. Oh, below greater than 1. Yeah, better gonna. I'm just checking if this is possible. More below or equals to 0. See if that's possible. Okay, not possible to do it like this. So yeah, you can use the if statements, I guess. Fishing if statement. Initial detectors, if initial detectors are greater than or equal to 0, and else if initial detectors are greater than or equals to 1. This one, Gallery, there are no detectors in the world. So if there are no detectors in the system, if the wait, what are we saying? No, we shouldn't be checking detectors. We should be checking pathogens. So what I'm going to do is, I'm going to define, a pathogen. So I'm going to say, I don't know how to represent it, but I'm sure it's just going to use an integer. So I'm going to say pathogen, the number of pathogens, and like so num, or what we are going to say int pathogen. So there's two ways. So maybe you can use a boolean. You can use a boolean to say maybe you say bool and say pathogen present. Then if this thing is true, then it means there's a pathogen. If it's false, then it means there's no pathogen. But then I'm not sure if this is how they want us to do it. Yeah, if there's a pathogen present in the system, the user must only have two options. Okay, let's do this one. So at the beginning, I think it will be false. Let's make it equals to false by default. So if I don't come in the setup and say world dot pathogen present is equals to false, automatically, if I don't do this, automatically you're over false. Like if you declare a boolean on or boolean something, automatically it get false. So even if I don't come here and say false, doesn't matter, it's going to be false anyway. So here I'll check if there is a pathogen present. So if there's a pathogen present, let me use the now check if there's no pathogen present, and else if a pathogen is present. So here, if a pathogen is not present, we're going to, in our menu, we're going to have two options. We're going to have introduce pathogen and quit. So see out. One, let's have a char option or is equals to this thing. It's 0, yeah. So if option A over introduce pathogen end line, then see out . quit. Okay, that's if there's no pathogen present. But then if there's a pathogen present, our options must be continue the simulation and quit. Continue the simulation. So if there is no pathogen present, the options are introduce pathogen and quit. If there's a pathogen, the options are continue the simulation or quit. So I assume I'm going to display the world here. Maybe I can going to clear my screen first. CLS. I'm going to display my world. Display world. Yeah. Now if I run it, obviously Rotamarsna. Oh, maybe it's see in official given message or prompt a user or entire option. Enter. So yeah, obviously Ertoma, we don't have a pathogen, so the option will be introduce pathogen and quit. So, yeah. Okay, let's continue. So if there is a pathogen in the system, the user must have two options: introduce pathogen or quit. When the user introduces a pathogen, it must be loaded, it must be placed at an empty location. So maybe let's do this same time. Wait, this one, let's call it B, option B. So B is for continue the simulation and A is for introduce a pathogen. Is that wise? It's not wise. Yeah, it's not because I'm already logic. Let's repeat a code. So I'm already a socket. I'm already a socket. And the monkey produce. That's what I was trying to do. So this one, I can say you are repeating code, so I don't know if it will have an effect. So what I was trying to do last time is I was just trying to reduce the thing. So after getting the option, we switch. So they're saying when the user introduces a pathogen, it must be placed at a random location. So I'm going to have a function to introduce a pathogen. So void introduce pathogen. So I'm just going to pass my world, my request structure. So we said that we said when the user introduces a pathogen, it must be placed at an empty random location. So this must be placed at an empty random location. So we're going to declare our random location. So this is int r generate random. This is from 0 world dot rows minus 1. generate and we got our location right, but then before we can place our pathogen, we must make sure we are not placing a pathogen on top of another pathogen, or it must be placed at an empty location. So we must make sure we're placing our pathogen on an empty location. So I'm going to check if the location, again here, this is the location. So location is defined by RMC. So I'm going to check if this location we got, if there is a space occupying that location. So I'm going to say world. So basically we're saying if the location is not being occupied by, if it's not being occupied by space. So if it's not occupied by space, we must generate a new location. Location. So I'm going to generate a new location up until the location we generate there is space. So if there is space, then now it's safe to place our pathogen. So this is also pathogen. Right. So Kamoki. So I don't know. I think I must switch here. This is weird. So I think I must switch here. So I'll say switch to Papa. And is A. And also case Q. This will be case Q. And break. Then we have the default. Shit. Break. And if option A can introduce pathogen, so just going to use our function to introduce a pathogen. So introduce pathogen, and pass in our world. Then Q, obviously we're leaving. So cout simulation ending 1 2 3. Simulation ending. Yeah, let's just say simulation ending. Watch one. And it means world dot status to be false. So that's under. So let's test that out. At the moment we don't have a pathogen, so I'm going to introduce a pathogen. So I'm going to say A. You see my pathogen is there. Then you can see, wait, this thing must change. So now there's a pathogen, it means this thing must change. My option must change. So why is it not changing? Why is it not changing? So so it means in the introduced pathogen. So after I have introduced the pathogen, I can say pathogen present is equals to true. Then yeah, then you'll see after I've introduced my pathogen, my menu will change. So A, introduce my pathogen. See my pathogen is there. Then my menu changed. Continue the simulation or quit. Diagonals. So if you got a age, let me pause here. Okay. Default or CD. So under default for CR valid option line then kaposa. So oposa rushimisha system system pause. Onyaka kwanodia function ya pause. Onyaka. So if car age invalid option, then I pause. Then I quit. Then yeah, gonna quit the fella. Then sharp you if there is no pathogen present in the system, the user must only have two options. Okay, that's that. All right, Tulani.
Sorry, can you go back to the code? Code switches cases, man. Yeah, code cases. Okay, for all right. So for quit, you say out simulation thing, and then you set your status, but your boolean or eBay false. That will working to terminate everything to stop the running, ne?
Yeah.
Oh, okay. No, I wanted to see that only. Thanks.
Sure. So yeah, that's the part if there's no pathogen present in the system, then when you introduce a pathogen sharp, we go to the next menu. So if there is a pathogen present in the system, the user must only have two options: continue the simulation or quit. So of course we're now. So at each step of the simulation, while a pathogen is present, the following must happen. While a pathogen is present, the following must happen. So step 1, create copies of detectors. Create copies of detectors. So for each detector, if the Euclidean distance between the detector and the if the Euclidean distance between the detector and the pathogen is less than the simulation threshold, the detector is stimulated, which means it must be cloned. So what I understand, we must create copies of detectors. So how do we create copies of detectors? First of all, rechaga if a Euclidean distance a between the detector and the pathogen, if a less than the stimulation threshold, then the detector is stimulated, which means it must be cloned. So sharp Euclidean distance. So Euclidean distance is distance between detector and pathogen. Then Ravalli stimulation threshold. So if Euclidean distance, so if Euclidean distance is less than stimulation threshold, then it means detector tanze ibe cloned. So kona molore iba duplicate. So cloning a detector means that you must create two new detectors. So we must create two new detectors and place them within one block around the current detector randomly. If a selected block already has a detector, there is no need to search for a new block. Just replace that detector. So you, the programmer, must choose the stimulation threshold, value of your own, all right? Value of your own, value on your own, and make it a constant in the header file. Play around the different values and see how it affects the immune system. So yeah, let's define our stimulation threshold. You must make it a constant. So const stimulation threshold. Oh, is an integer. Is it an integer or a double? Let's make it an integer. For now, maybe the idea I get 2. 2 as in I get 3. Idea 3. Part of our own. So you, the programmer. Oh, program again. you must choose the simulation threshold value on your own. Yeah, it's directly on my own, sure. And make it constant in the header file. Play around the different values and see how it affects the immune system. So yeah. So the program again I choose stimulation threshold. So yeah, ke choose way. Like the choose the programmer. So yeah, arjing into it. Create copies of detectors. So what can kino develop into it? Function Euclidean distance. Mara I remember they once told us this function. But then yeah, I think I remember it. Okay. So I'm going to have this problem must it be a double or must it be let's make this thing a doubles. Must it be, yeah, let's make them doubles. So double, so this one I'm making a double. So perfectimus kamagara. So could your function here your calculator, I'm going to make this function to calculate a Euclidean distance. So Euclidean spelling. So Euclidean distance. So Euclidean distance the function arena. So it take any the row, the column. So I got a Euclidean distance is between the location of the detector and the location of the what's this? The location of the what's that other thing? The location of the threshold. A calculator distance Euclidean distance key distance between detector and a pathogen. So something ke pass location ya pathogen and location ya detector. So I'm going to have a int, so pr ke row ya pathogen, then int pc. So this is the location. Again, remember location ke rlc ke row c. So this is the location of the pathogen. So pr and pc are the location of the pathogen. So now I must have the location of the detector. So dc detector dc and int dr and dc. So function key a calculator Euclidean distance. So let me start with a location detector. Okay, so this is the function perfect. Yo function naona ke pasa location ya detector le location ya pr ya pathogen. So then sharpo it return a double. So let me go define it. Not sure if I remember it well, but then I will try. So Kamoki gonna return. So this one will be your square root. Hey, math. Hey, I think you know square root. Error. Can late you know dr plus pr squared. So gonna maybe get times 2. Yeah. Squared is 100 times 2 or 100 sorry. Then root. So circle type lang yun. This thing. Kila ya actually dile manash. Square root is normal. ke kae ke ngwala kae ke ngwala mo ke dai la na re bontsha jang bot rooms I want to show you view more options. I want to show you the working trailer. Rooms. Yo, kile jor. Kinyo ko doon siya na. Ano gilawon siya na kain trailer man. Show conversation. Askamoki. As under view. Color top. Hide me. Color display. Askamoki. Apps. Askamoki. Then more. Record. Video effect. Audio effect. Language and settings. Call me help. Siona. More video effect. This is going to launch a bot that like a lurking into like bot then kahono wala muki kalongwalela function ya wona. Okay, hi, television radio. Yeah, whiteboard. Yo, naging trailer na mo. Yeah, ish. Naging mas siguro. So, function nila or Kirwai. Norway. X Norway. And x1 plus x2 squared u plus que type in dia boyamu que malam so agar we have point 1, so point 1 then point 1 we redefine ka x1 le x2 le y2 le y1 I mean le y1 then we have point 2 then in a x2 le y2 so re nyaka Euclidean distance re kira ka this function rore x2 6x2 minus x1 you should remember this function. You are fresh from high school then mo ke y2. So like what function do you guys remember this function? Persuade to learning which allowable. Okay, but then k on I'm not sure if mogi minus, but I will research. So Euclidean distance. So yeah, k on. I want tango x2 minus x1. So k on. So hurry. So the square root. Which root square root and stuff. Sanjo rebel header file algorithm or CMath. Yeah, come to CMath. So let me check some math. So mark square root again. So under square root 2, remember we have this thing minus ish already squared sanjuro shumisheng. So squared sanjuro shumisheng. Squared shumisheng.
Maybe. Yeah, times 2.
Sanjuro times 2.
Yeah, I wanted to ask for maybe I don't know maybe. Times 2. Times 2 is not double, isn't it?
So
I guess
can
do like do this. Like this, yeah, 2 brackets, like times itself again. Oh, that's what I wanted to ask.
I think yeah, we can do it like that. And yeah, monkey. So barring distance from what? This is from between the detector and the pathogen. But between the detector and the pathogen. Between the detector and the pathogen. So if you can remove it, PR. Yo, seasonal thing was to get oh PR plus TR. Yeah, this is monkey square root of H minus. Oh, K plus or minus. K minus agar.
Minus, yeah. Center. No,
Minus K mo agar.
Oh, yeah. Give minus, yeah. Yeah? I'll check.
This whiteboard let's mail.
Copilot nearing.
Yeah, K minus.
K minus, plus 6 center.
Then kamu Q over PC. Oh, kita itu dia. Come on. Oh ya, Kiona. PC minus lagi PC minus DC. Then baca square root. Check or Roshimi square root na. So special cannot be special. Square root. Share ke fento ChatGPT. Enggak. Kau cakap polar logic jam meter dia doang. Let's check. Yeah, CMAX. And then square root, so ke yona. Eh? So yeah, hypotenuse. So if you are trying C++11, I should say C++11 anyway. So you are on the right track, but there's a small syntax error, the multiplication part. So each monkey, something know for multiplication. Let's check if that was the only error. Oh, that was the only error. So masaksalo na
Yeah.
function e ke yona ya calculator Euclidean distance. So let's ka level to tswelela yena ai professor ene tsantsere re ke di function ya go copper the detectors. Yeah. I'll keep it. So I'm going to make a void function. Let me say copy make ignore make copies. Make copies and again pass it in game world define. So what's so for each detector. So for each detector, so gonna to make out loop through my world. The copy function. So to loop through my world, I check a more on a detector. So if world dot read at r, let's see if this is a detector. So yeah, so for each detector, if the Euclidean distance between the detector and the pathogen is less than simulation, okay, so ronyaga Euclidean distance. So if Euclidean distance between the detector and the thingy, so Euclidean distance mostly rho, so this is at r. So if I choose sensor nyake location ya pathogen. So I don't know, maybe we should guide Sakamuki or just before this or other ring re Kamuki re save it. So let's make a for loop or let's make another function to give us the location of the pathogen. Already at the same time is discussing. So I get it could declare int no yeah could declare int is there another location name ya pathogen right int pr int pr int pc again ion so for Kenya ko loop through my world then if this is the pathogen, so if that's the pathogen, then I'm going to set the location of the pathogen. So for the pathogen pr is equals to r, so pc is equals to c, and yeah, this is how I'm going to get the location of the pathogen. So here comment there get location of the pathogen. So to get a location of the pathogen, alright. Then after that, calculate a Euclidean distance between the pathogen and the detector. So this one will be to calculate the Euclidean distance, go pass in the detectors. Erge Euclidean tricky SDR. Carry dr dr, then mo ke re dc, dc, then to go create the Euclidean thing, something get pass in, create the Euclidean distance, something get pass dr, dc, r, and get pass pc. So pc le pr la di bona ke di kira kaya skara here. Then something to check if this Euclidean distance is less than. So if this is less than the threshold, the simulation threshold, so simulation, kan receive yang tell receive as stimulation. So stimulation threshold. So if this is less than the stimulation threshold, for each detector. So we'll go each detector. So if the Euclidean distance between the detector and between the detector and the pathogen is less than stimulation threshold, the detector is stimulated, which means it must be cloned. I want to get it forward. So
Rabon.
So if the Euclidean distance is less than the stimulation threshold, then so before you ask about stimulation threshold, read Ilegamoki, a programmer, but you can choose a random. The programmer must choose to set it to a random number of his choice. So a programmer chooses 3, so Shikikamoki is a constant. So let's go level. So if it's like this is if it's the Euclidean distance is less than this thing, so we make a copy.
Okay.
So how do we make a copy? So cloning a detector means that you must create 2 new detectors. So we must create 2 new detectors and place them within 1 block around the current detector randomly. So we're going to create 2 new detectors. 2 new detectors. So the 2 new detectors, we place them randomly around. So ito but then let's just do it. So looking yeah, anyway. So purpose so as long as it so ito ba ito so yeah, it will be longer, but then as long as we understand. So they're saying we must place two new detectors. Okay. So obviously, our detector is represented by this value here. So now go generate a random location around the detector. So two new locations. Got a PR1. Actually, maybe we're gonna choose one. Kurra generator first location, then refuge variable generator the other location if you want you can do that. So it's not R PR. No, let's say mukir location or place so R CR I get cloned so CR generator new location so originate a location around like Gushimichi method I'm going to use that the method I used in the last practical in the last simulation. So Moki Kore this is CR is R plus then I'm going to generate a random number from -1 to 1. So remember to move so this thing will allow me to only move 1 unit. So if this is -1, if the random number is -1, so remember, so it means I'm going to, let me do this. I'm going to say int cc, and this is c plus So Ricky, this thing, for me to say R plus generate random from -1 to 1, which are this like this is more simple because same time I know whatever I get, whatever CR and CC I get, that location will be one unit, will be one step. Like which are like for example, if if this function generates -1 for example, and for C is generates 0, it means I'm moving up one unit up. I get to move up, you just decrease the row by 1 and the column stays the same. So can do it. Then if this is 0, it means the row stays the same, and then if this is -1, so you will move to the left one step to the left. So this thing, like inshallah, move one step. Then I got my location there. Then after getting my location, before I place my my detector, my clone detector, I must check if I'm placing it where there is space. You understand? So check or is it within bounds. So grid at CR and at CC, if this is equals to space, and also if these are within bounds. So tochaka CR PL. So if CR is within, it's better if you reveal, it's better if you shimisha put it into la sharp or ubele function is in bounds function nanila. So maybe like no idea mara to save time. So if CR is greater than 0 and CR is less than or equals to world dot rows -1, then bafetara cheka CC. If CC is greater than or equals to 0 and CC is less than or equals to world dot calls -1. So Muki kinocheka if my location is within bounds. Then akacheka if where I'm going there is space. So if these conditions are true, I'm within bounds and there is space, then that's when I place my detector, my clone detector. So I'm just going to say grid at CR and at CC, then I make it equals to a detector. So remember I must do it twice. So Mukitaweki place the first one. I can remember I must place 2 new detectors around. So it means I must do this again. But then remember here already I've declared these things here, so I mustn't declare them twice. So and that's that. So that's make copies. That's how I make copies. So Kamoki continue simulation. I get my only options over continue simulation or quit. Then after kito switcher whatever option I got. So I'm going to copy this one. Oh well, Spitfire. So to copy and key. Then everything it not the same except for Moki. Moki I introduce a guide there. Kamoki ke make a copy. I make copies. So I'm just going to pass the world, and just like that. So just like that, make copies, then everything else stays the same. So let's check if I'm done. Cloning a detector means that you must create 2 new detectors and place them within one block around the current detector randomly. If a selected block already has a detector, then there's no need to search for a new block. Just replace that detector. So Moki, ka function here make copies. I've done that. Okay, so you no so ya bereka mara. I check already. So let me run. So what's the error? So what else? Push dialogic key to tr dc. I forgot to change them. Then monkey dr dc. Monkey tr dc. And yeah, I can have pathogen. So let me introduce a pathogen. Okay, I have introduced a pathogen. So now gotta continue the simulation. I gotta continue the simulation. If Euclidean distance between this thing and this thing, if it's less than the threshold, then logic do double. So obviously di ka se di copy ke ra bona di gole. So obviously our thresholds ke 3. So actually, I don't think there's only pathogen. There's any detector that's going to duplicate. So re zameng gape re bone if re ka beya pathogen closer nyana. So yeah, I think this one must duplicate. So let's check if it works. So A, you see it duplicated. Hey, but why the monkey hole? Oh yeah, ke one step. La bona diagonally one step. Then the monkey one step. So it continues the simulation happen. Check what will happen. This one will make its own duplicate, then this one will make its own duplicate, and this one will make its own duplicate. Let's go on again perfect.
Sure, yeah, everything.
So la bona iki it closer. So jeki di take the closer no so iki yodia di copy jana T2, iki di copy jana T2, iki di copy jana T2. So remember, agar yo chance agar the example ga iki agar chance place two copies around it. So if the random location imoki, so you know if you are namoki mo udi maiki. So as you can see, so this one I assume already pedi. Then let's so it's yeah it's ngarga assume mara ngana very little 1 2 3. So this one possibly keki, then this one.
Oh yeah. They placed the clones, they are placed randomly, né?
Yeah, one step.
Okay. One step parking step radius of the
So labana tuto dia bang. Yeah, kena na simulation yo endana moki. Oh yeah. Kusare isa jora pel. So kasa jala pel because take it around. So take it dealing less than 3, dealing less than Euclidean what dealing less than 3. Imina gore do continue go dia dilo do continue go make di copy mara agere obvious do gonna place a copy around Jonah fela, so do not place a copy around Jonah fela, then this ones di gole. So do ka sabale so kana you gonna fela na moki I think so yeah language why is actually pele na you understand why is no longer continue. It's still continuing like this one closer. They're still generating, they're still making copies around the thing. But then obviously they're just putting on top of those other things. So yeah. So let's go to step 2. Update the detector population. So after completing step 1, we have step 1. So after completing step 1 is this one. Okay, so after completing step 1, remove N detectors. Okay, remove N detectors that are furthest away from the pathogen to avoid overpopulating the system. So any number of detectors, so remove any number of detectors that are farthest away from the pathogen. So that are farthest away from the pathogen to avoid overpopulating the system. So so remove any detectors. So those ones that are far, we remove them, but then we choose how many we want to remove. So n doesn't represent any number of detectors that are far, then we remove them. So you, me, so you the programmer, me the programmer, you must also choose your own value for n and make it a constant in the header file. Play around with the different values and see how it affects the immune response. So okay, let me declare my n as the programmer. So const, so obviously keep on my integer, so n is equals to nakanya go idea 4. That's the program I want to make it 4. So const int 4, then come out yo, this is work on top of work. So let me make a function or if it's simple. So I'll say void remove detectors, then it's gonna pass a world fella. So copy, let me implement it. Farthest, so it's not, so I assume you must look for the farthest, Maraj. Kalap, to look for the farthest. So I think obviously first of all, don't loop through our world as always. Through the world. So I think row checker the detector, so checker detector. So by farthest I mean, so by farthest is because it will take time to look for the farthest, like the farthest. So you should remember. So I think so. I have n. So I have n. So I'm going to say maybe Eric getting get n. Eric get a temporary. Get a temp n is goes to my n. I get n. I got the constant I change. So make correct. If so, instead of saying Euclidean distance a greater than this thing, or if it's less, can also if it's greater. If it's less, no, if it's greater, farthest. Am I doing this right? No, so got greater. I get keshaka sila dilim hole. So if it's greater, then sharp if it equal, then this matter check the feathers. Number I'm not going to check the feathers. I'm just going to check. I'm just going to check. To at least check the feathers. Maybe I can enter two nyana. Okay. Five to accommodate feathers at least. I'm just going to check the ones that are far, not farthest, but those ones that are far. Because checking for the farthest just complicates things even worse. So here, if this thing is far I must remove it from the thingy from the world. So I'm going to say world. I'm removing one detector. So world.create at r. I wanna make a problem usually. So as always, lawana mogi kinali PR le PC. So tsanwe ke dinya ke gape. So lawana mogi, this is how I looked for them. So I'm just going to copy this thing here. Then yeah, now I have them. So this one I'll just say is drtc. Sabu ka placer mobiling like I remove the pathogen, I mean. So to remove them, I just make this thing, I just put space on top of it. I just say space, and just like that I remove the detector. Oh wait, first of all I must check if the current location is the detector. So if world.create at r, then c at gr net dc, if this is close to the detector, then I'm first going to check the distance between that detector and the pathogen. Okay, then I remove it. Then I'm going to make temp, so I'm going to say temp minus minus. So before I remove, I'm going to check, I'm going to say if temp n is greater than or equals to 1. I gotta remember I must remove this thing. I must remove n number of detectors. So n number of detectors, remember the number of n gekidia. So I'm the one who chooses it. The programmer is the one who chooses it, and it's constant. So I'm going to make a temporary value. So each time I remove a detector, so I'm going to say to decrement this, sorry, at least I remove the number of n detectors. So let's run this. So did we use that? No, we didn't use a remove detector. So we remove a detector after, I don't know, maybe we can just use it here. We can say after making copies, then we remove, I think anyway, yeah, after, then we remove detectors there. I don't think it matters. We can do it here. So now if I run, so introduce pathogen, this is A, and you see, is there any 1 2 3? Right. A is ka fela tsona dikgole. Remember I did that, I said plus 4. Let's just say if it whole and j I did remove not plus 2 nyana, then monkey are removing 2, it's gonna remove a inch and distance, yeah, then are placing more detectors, maybe 20 at least. Then sharp introduce our pathogen. Okay, that's our pathogen. And okay, wanna go yeah, now That's that. So like logically, the point is, I get here. Remember, the point is to check how the immune system responds when a pathogen is injected. So when a pathogen is injected, like all the detectors, they get stimulated and they attack it. You can see these things is that like they moved from where they were and they attack this pathogen. So that's how an immune system
Okay.
responds to a pathogen.
Sorry.
So you get it now.
Yeah, sorry. Can you run it again, like from scratch, like before and
Okay, I run it. Then there is no pathogen. I introduce a pathogen A, then introduce a pathogen. So that's my pathogen. Then now continue the simulation. See, those other ones have doubled. Okay. Now I'm finding an error. Moses. What's the problem? What's the problem? What's the problem? Hey, Kokira, I got a problem. Okay. Introduce pathogen. That's the pathogen. Mm-hmm, 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 mm-hmm. So it got attacked. I don't know. Capilla, I got an error. I don't know where it came from. You can see they attack the pathogen. Let's go, let's go, let's go, let's go, let's go. Yeah. Use pathogen. Okay. I don't know about you guys, but then simulation it's not as hard as we thought it's hard. So yeah, let's check if we are done. So after completing step 1, remove N detectors that are furthest away from the what. So it is you ready remove. So your programmer, me, so they're saying I must also choose my own N and make it constant in the header file. Okay. Play around the different values and see how the immune system. Yeah, I should play around with those number what. So yeah, then we get our total. Then we're done. And just like that.
total.
Yeah, recitile.
Yeah, no.
So linakaneng alam ka re simulation easier. Abala sa stika or what ntela game easier.
Hey, I wanna know. Huh. Well, nga simulation. We're talking easy.
Mara fast kinang na phone na agno
Yeah,
re easy.
yeah, it's fast yan.
Yeah, fast easy. Tagusha. So I say lena la stika la opinion ya lena or game journaling easier. So nagar simulation easy because you know the antoite fail and then yeah, boom.
It's like the practice. I think in your what when I would say a lot of things like functions like do this. You will be able to like make everything go because until there is no movement or I mean you the user
Yeah,
doesn't like input commands or something.
yeah,
Like it just happens on its own. I think it needs you to know how to make everything happen on its own.
yeah. Mara so Mara it depends on the
See the
scenario
video.
and stuff.
Uh,
So yeah, Lungelo go fetsa ko diang ko qeta mos. So azivaleng le session se ulala. So re tla ngwala botse go sasa. So I wish you all the best. Go get them distinctions. So yeah, le be le boshiu bo botse.
Thank you, man. So last session e ka sane ne.
Ai ka mogano ke last session. A ke le ngwala go sasa.
Mali bangwe ba ngola ka Saturday.
No, like ke 4 days what. So this is the last session.
Oh,
So yeah, this
4 days. Oh,
this concludes our boot camp anyway. So yeah, kita bonana bakhethu kita senda solution le video le link ya video. So sharp fede.
sure.
Yeah, love and kisses Lungelo. Stop recording.
Boy, didn't I?